Today we are talking about solving for a variable. It's also called literal equations. With the literal equations, these are equations that have two or more variables, and most of the time what we're doing is just manipulating the variables, moving them from one side to the other in an effort to discover how best to find the solution for a certain variable. They usually represent some type of formula, math, science, engineering, things like that. The problem must tell you which variable that you are solving for, and you solve them just like you would as if they were any other, if the variables were other numbers. So when we have a single variable equation, this is something you're familiar with. We have a 3x plus 7 equals 16. We only have one variable, and we can solve for that easily by just reversing our order of operations and getting it down to where we only have a variable with a solution. With literal equations, you have more than one variable, and they want you to solve the equation for the stated variable. So this one is 3x plus 7y equals 15, and they want us to solve for x. So what they wanted us to do is to get x by itself with everything else on the other side of the equation. So the best way to do this is to decide which side you want your variable on. It's already here on the left, so I'm going to leave it there, and I'm going to move this 7y, and then eventually I'll move this 3. So the first thing I'm going to do is I'm going to take and subtract 7y from this side to move it to this side. So 7y is no longer on the left. I have 3x. I like my variable to come before my constant, so I'm going to put my negative 7y, and then because 15 is positive, I'm going to put plus 15. Now, I have my variable on the left, but it's still not alone. I have to get rid of this 3. So I'm going to be dividing everything by 3. So x is going to equal, I can't simplify this anymore, I'm going to leave it in its improper fraction form. Not equals, plus 5. So this is how you solve a literal equation. You're just trying to get what you're looking for on its own on one side of the equal sign. So we have these formulas that we use when we are finding volume of, this one looks like for a rectangular prism, and they want us to solve for L. So volume equals length times width times height, and they want us to solve for the length. So I need to get the length by itself. When I look at this, I have the W and the H. This is all multiplication. So if I take, to move these two, because it's multiplication, I'm going to divide by WH, divide by WH. I can't simplify this anymore. It's gone from this side, and all I have left is length by itself. If you choose to rewrite it, it's fine. You can put it on the left. Just make sure that when you are moving it from one side to the other that you don't change the order that they look at. Okay? Alright, this one's for perimeter. Perimeter equals 2 times the length plus 2 times the width. Solve for the length. Again, I'm solving for this length. I can move this 2w, so I'm going to rewrite this so I have more room. I'm going to move the 2w first. So it's gone from here, so I have the perimeter minus 2 times the width equals 2 times the length. And now I want to divide everything by 2. So I'm going to have p divided by 2 minus w equals my length. These canceled out, but I couldn't do anything here because I don't know what p is, so that's why the p for perimeter is still over the 2. These are scientific formulas, looks like for velocity. So take a look at it. We're solving for A, so I have to find A. So I would need to get this by itself. So what would I need to do first? If you said move the V with subscript 0 first, that is correct. When I do this, I still have a t that it's attached. So I need to, this is multiplication, I'm going to divide by t. Because those cancel out, A is now on its own. This is for finding the temperature in Fahrenheit when it gives you Celsius. You can also use it to find what Celsius is going to be if you have Fahrenheit. So we're going to rewrite it. And I want to get C by itself, so I need to get this C here by itself. So I'm going to subtract 32. Still want to get C by itself. I have this fraction, so I'm going to multiply by its reciprocal. Reciprocal. So that cancels out. So C is by itself, and if I take 5/9 times the Fahrenheit minus 32, I would get my degrees in Celsius. I'm going to leave it like that because this formula works better this way. It gets to be very messy if you continue on, and this is really all the further you need to go. If you have any questions, please come see me. Sometimes these get to be a little tricky. So think about how you would do this. You're going to solve for m, so you're going to subtract the b from both sides. Then you're going to divide by x on both sides. This one here, you're solving for x. So you would have to subtract c from the s, and then you would have to divide by the c. Actually, let's do that. So it would be minus c. So we have s minus c equals xc. Divide by c. So when you do that, you're dividing everything by c. Just remember what you do to one side, you do to everything. And when I'm looking at this, this cancels out to be a 1. So then I get s over c minus 1 equals x. Because these c's cancel out and those canceled out. Okay? All right. If you have any questions, come see me. Thanks.